Hi, my name is Andrea and I'm going to talk about how physics are applied in catapults. In ancient times, catapults were one of the most effective weapons in war. Various types of catapults have been used by the Greeks, Romans, and Chinese. Today we're going to learn how physics apply in the use of these objects. A catapult is a launching device that allows us to experimentally observe projectile motion. Once the ball is launched, the only forces acting are gravity and air resistance. Air resistance accelerates the ball in the opposite direction of the travel. Gravity accelerates the ball in the negative y direction. This works because energy can be converted from one type to another and transferred from one object to another. Physics are required in order to be able to use the stored energy in a catapult to hurl a projectile without the use of an explosive. The science behind catapults is that once the projectile is released, the only force it is subjected to is its own weight, resulting from gravity. When a projectile is released, it has both horizontal and vertical components of motion. However, this can be analyzed separately since gravity does not affect horizontal motion. The result of this analysis produces an equation for the distance a projectile will travel if it is released with a given initial velocity at a specific angle with respect to the ground. If you experiment with different values for the launch angle, you will find out that the 45 degrees is the best angle to maximize its efficiency for your catapult. The catapult must have vector quantities, for example, the speed, force, or acceleration which the projectile will take when launched. Also, the catapult must have a determined direction and sense to hit the target, or else it would miss. The three primary energy storage mechanisms are tension, torsion, and gravity. In order to make a catapult useful, we will want to be able to predict where a projectile will land after launch. To do this, we need to calibrate the catapult. The main types of catapults used were the trebuchet, Madrigal, onager, and ballista. The ballista catapult used twisted rope as the energy source. The bowstring would be winched back to set tension. The mangonel catapult consists of an arm with a bowl-shaped bucket attached to the end. In the bucket, a payload is placed. Upon release, the arm rotates at a high speed and throws the payload out of the bucket towards the target. This type of catapult was best suited for launching projectiles at lower angles to the horizontal. However, this type of catapult is not as energy efficient as the trebuchet for the main reason that the arm reaches a high speed during its launch. The trebuchet catapult was the most accurate and the most efficient in terms of transferring the stored energy to the projectile. This one worked by using the energy of a falling counterweight to launch a projectile using mechanical advantage to achieve a high launching speed. The onager catapult, instead of using a falling counterweight, it used a torsion bundle to rotate the arm. Because of this design, it allowed for greater throwing distance. There are several types of catapults, one of them being the tension catapult, that works due to the fact that they store their energy when a metal, wood, or horn bow is drawn. Another example are the torsion catapults that are activated thanks to the force stored when twisting some kind of rope. There are also the counterweight catapults that work on the basis of a counterweight with a mass much greater than the weight of that projectile. The advantage of this war machine in comparison to the previous one was that this could store energy without any leaks or changes. The previous ones could not do that since they lost strength over time, even they were damaged if they were not fired in a short period of time. Finally, there is the traction catapult that works on the basis of human impulse, and they use the lever and the sling to increase the output force of the projectile. In conclusion, without physics, catapults wouldn't be able to work. There are a lot of factors that should be taken in consideration in the making and use of this tool. Also, this helps us to be informed of the ideal angle it should be projected at to be able to hit the target properly. Thank you!